Right, let's have a look at these then. I've written them all out. It tells you what the substitution to make is, so that's already decided for us then. So let's get du dx to make the substitution. Differentiate this, we get 1. So du is equal to dx, isn't it? So I equals then. So it's u to the 6. So it's u to the 6. Okay. Now, x, what's x equal to then? Would equal u minus 1. And then we get du, don't we? Because dx can be replaced by du. So you notice how we could just replace the x by u minus 1, couldn't we? And can you see this is easier than that integral? Because here you'd have to expand that bracket. Here you've only got to just expand this bracket here, which is easy to do because it's just two terms. U to the 7 minus u to the 6, isn't it? Du. So that's equal to then u to the 8 over 8 minus u to the 7 over 7, which is equal to, now I'm going to cross multiply the fractions, and I'm going to take a 1 over 56 out at the bottom. Cross multiply 7u to the 8 minus 8u to the 7 over, and then cross multiply the fractions and put it here. Okay, that's what we've got. Now we know x goes, when x is 0, u will be 1. So that's the value here. And when x is 1, u will be 2, won't it? 2, 2, 2. So that's what we need to work out. Let's try and do it here. 1 over 56. Put 2 in and 1 in. And it's a simple calculation. Hopefully you get 769. So I'm going to leave you to worry about that calculation, because it's only a matter of typing it in the calculator. It's awkward numbers. Top value, put 2 in all the way along. Take away the bottom value, put 1 in. Here you'll get 1 minus 1, won't you? Which will be plus 1. Okay, that's that one. I'm not going to do the tedious calculation there. The rest should be okay though. So here the substitution is this. So du dx then is equal to, this is x to the half. So it'll be a half. X to the minus a half, 1 less. Differentiated, and that constant goes to 0. So this is equal to a 1 over 2 x to the half, isn't it? So the x to the half dx on top, we can move that up, x to the half. Yes, okay. Well, again, what are we going to do here? It's rather interesting, isn't it? So let's see what happens then. So I is equal to. Now, what happens here? So we've got, this is root x. Now root x is equal to u minus 1. Isn't it? See, u minus 1 is root x. Then we've got root x plus 1, which is the u, isn't it? So that's an easier fraction to divide out. But we've got to put the dx in. And that would be 2x to the half du, wouldn't it, the dx? 2x to the half. See that 2x to the half comes up with a du? And we can replace the dx. But the x to the half is u minus 1, so it's a u minus 1 squared, isn't it, here? Okay, good. So that's going to be something we need a few more lines on. So let's just move this out of the way. And then we'll proceed with this problem. Not as simple as they once appeared, are they? But the problem is coming into picture, isn't it? So all we need to do is expand this bracket, put the 2 at the front, and then we've got u squared minus 2u plus 1 all over u. Isn't it? U squared minus 2u, when you expand the bracket, plus 1. There's 2 lots of, so I've put that at the front of the integral. Split this up. U squared over u is u, minus 2, minus 1 over u. So that will equal 2 lots of u squared over 2, raise the power by 1, divide by that number, minus 2u. constant integrates to constant times x, minus the 1 over u integrates to ln of u. Now the bounds, well, this went from 0 to 1. Here's the substitution. When x is 0, u is 1. So it went from 1 at the bottom. And when x is 1, root x is 1. 1 plus 1 is 2, so it goes from 1 to 2. So put that in there, and we can work it out. So it should equal then, try and leave enough room, top value, take bottom value, put 2 in, 2 squared is 4, 4 over 2 is 2, minus 2 2's are 4, minus ln 2, underneath put 1 in, 1 squared is 1, so that's a half, minus 2 1's are 2, minus log 1, which is 0. Okay, so we've got 2 lots solved then. 2 minus 4 is minus 2 plus 2 minus a half is the number. See, that's a minus 2. We've got a plus 2 here, so it's just left with a minus a half when we run the minus through. And then we've got minus ln 2. So that's equal to minus 1 minus 2 ln 2. Now the 2 ln 2 is a negative here, and it should be a positive. Oh, plus 1. So I decided to write it as minus here, see it? So there's the mistake. So that's a plus. That's a plus, and this is a plus. So this will be a plus. So it's 2 log 2 minus 1, which is what we wanted to show. So a little error there, but we spotted where it was and corrected it. So 2 log 2 minus 1, which is what we wanted to show here. That's B. Now part C then. And we'll move D down even before we start. We'll move it up in a bit if we can. Hopefully that's enough room. So part C. So du dx, differentiate with respect to x, this differentiates to e to the x. So that tells us that du is equal to e to the x dx, which is up the top. So I equals then, e to the x dx is just du, one lot of, and e to the x plus 1 we can replace by u. So that's equal to the natural logarithm of u. When x is 0, e to the 0 is 1. 1 plus 1 is 2, so u is 2. And when x is log 2, e to the log 2 is just 2. 2 plus 1 is 3. 3. So that's equal to ln top value minus the ln of the bottom value. Minus you divide top over bottom. ln 3 over 2. Which is what we wanted to show. Now let's move on to the last one. That one was okay. Okay, this one here, x equals u squared. What's going to happen here then? So dx du is equal to 2u, isn't it? If you differentiate this, dx du is 2u. Now that will tell us then that dx is 2u du. dx equals 2u du. So I equals then 1 over, now x is u squared, root x is going to be root of u squared is going to be u, and then dx is 2u du. Okay, good. And then there's a u common underneath, so let's take that outside the bracket. We'll have u plus 1 times 2u du. The u's cancel, and we have the integral of 2 lots of 1 over u plus 1. And we've done these integrals before, haven't we? du. Remember ax plus b in their form? So this is just log 1 over a, which is 1, of log of u plus 1. there's two lots of it. Differentiate this to check. Log of something goes to 1 over the something, multiplied by the something differentiated, which is 1, and 2 ones are 2, so we get that. Now it's a definite integral between 1 and 4. When x is 1, u squared is 1, so I'm going to take u to be the positive value 1. I'll go for the positive side. And when x is 4, u squared is 4, and then I'm going to take the other positive value. So square root 4 is 2. So between 1 and 2. So we got that integral then. We could leave the 2 outside the bracket. 2 lots of, and between 1 and 2. So it's equal to 2 ln 3 minus ln 2, isn't it? Top value take bottom value, put the 2 in, ln 3, put the 1 in, ln 2, which is 2 ln, minus you divide top over bottom, the logs, 2 log 3 over 2, which is what we needed to show.